Today's the 27th. No, you don't gotta raise it. This is what we're gonna do. This is chapter 6-1. What we're gonna do, if you take a look, we have a function called f, and then we have a whole different function called g. We're gonna do operations with these functions. So 6-1 is called operations with functions. And initially it's going to seem a lot like combining like terms. No, nothing's going to get easier. I've said that every time you guys ask that. It doesn't get easier. Okay, so we have an f function and g function. We're going to add them together. This means add f and g, and this means subtract f and g. This means multiply f and g, and then finally we'll divide f and g. So you have done these things before, but not maybe seen that function notation. That's all that's called is the function notation. So adding f and g is just combining like terms. So write them side by side and combine like terms. F plus g. F is given and g is given. So I put the f in parentheses, put a plus sign in the middle, put the g function. So that's f added to g. Drop your parentheses and combine like terms. Correct. There's a 9 over there. So you could drop those parentheses right now. So this just tells us what's in the equation. So like if this was a 2, it would mean take the x's out and put a 2 in. So you kind of just ignore this x. You can just ignore that x now. So Kaylee said, why do we even have to write these parentheses? And she's right. If you can see that we're just taking that equation and adding it to that, you don't need them for addition. 1x squared added to another x squared makes 2x squared. I really want to see you write the function notation with the sum. So I want to indicate with my answer what operation I'm learning here. F added to g gave me this polynomial. That's the answer for F plus G. Number 2, we will subtract. I added 12 and negative 9. Wait a minute. Yeah, they're like terms, they're the constants. Alright, with subtraction, the parentheses play maybe a more important role. You know, you have to distribute that minus sign. I've already done that this year. Multiply it into the parentheses. So change the signs of whatever the second function is, and then combine like terms. X squared and a negative x squared cancel. End up with just a binomial. And I want you to write the operation that gave you that difference. So I'm going to indicate it was f minus g that resulted in 7x plus 21. And you guys practice multiplying polynomials when you guys did those cube problems. And that's chapter. You had to do the length times the width times the height. So you'll, for number 3, we'll multiply f and g, and then number 4 will divide f and g. Operations with functions. You have to what? Yeah. So for multiplication, I don't see anything in between parentheses. Just a parenthesis right next to a parenthesis. That'll make a product. So you can distribute left or right, whatever you're comfortable with. I'll multiply x squared times x squared. With multiplication, you add exponents. We're just multiplying. X squared times a negative 9. Negative 9x squared. Now I'm going to multiply the 7x through. 7x times x squared will make 7x to the third power. And 7x times a negative 9. Negative 63. Now we'll do the 12. Yeah, I like that way better too. So now we'll do 12 times x squared and 12 times 9. Numbers. That is a lot. Let's combine them. Let's combine them. Let's combine them and shorten it. So the product, I'll use my function notation so the people reading my math know which operation I did. This was f times g, the 4th degree polynomial. I'm going to put it in order, standard form. Yeah, that was a long one. Gosh, I kind of want to graph it. Oh no.
The 12 and 9. Because they have the same exponent.
Oh, it should be plus, that's all. The number 4 is going to be the trickiest one.
Just do synthetic.
Actually, we're not even going to divide it.
Are we just going to make it to a fraction and simplify it?
We're going to factor them and reduce them if possible. Factor and reduce.
I did too.
Oh, you did division?
Yep. You can just do simple synthetic.
I'll show you what I'm looking for here. So I'm going to put the f function over the g function in fraction form, and I'm going to simplify it in fraction form. I mean, you guys keep going with what you're doing. Keep going with what you're doing and compare it to how this turns out. Not necessary, no. Put the f over the g. Now, if possible, I think in your homework, the problems are a little simpler than this. You're not going to be able to factor, but if possible, you should try to factor the top and factor the bottom. So, like, what multiplies to 12 and adds to 7? 3, 4, 3, 4. And then this is a difference of 2 perfect squares. So,
So that be the answer?
no, like with fractions, if you, sorry, there is this with fractions, if you have the same factor above and below, you can reduce it. Just like, if we had 5x over 5y, I would cross out the 5's and make it x over y. I can do that with factors as well. These are the same, so I can reduce them. And the quotient, so I'm going to do f over g to tell the people looking at my math I divided, will be the x plus 4 over the x minus 3.
Ooh. What the freak, man? Okay. I'm not gonna lie, that's a little long.
That was the newest thing out of all of them.
I just don't understand how we can just eliminate those two.
No,
Well,
like, where did the 7 go?
This is multiplication, right?
Where did this?
And this is multiplication here.
Yeah.
Do you understand how I can cross these 5 out?
The division like overlays, but you're just
that
getting
with
rid
every
of a
time?
positive 3 that
Or
was
is that
in the equation. And,
So you only do a times c if it's like you can.
If you can factor, you should factor. I'm not sure. We don't normally do division when the degrees are the same. So when you did it, you put a 1 up top? Yeah. I'm not even sure. I never thought of that. So I think it's awesome.
Wait, how did you guys do it with synthetic division? It doesn't work. I got x plus 52. Yeah. That's so weird.
You put the 0 in and everything? Something about them both being a power of 2. Alright, there's one more piece of this division situation. This star goes to the quotient. It says indicate any restrictions in the domain. So you need to take a note on this. This is actually a huge theme for like chapter 7. So this is like a preview for you. This is still part of number 4. Restrictions in domain come from undefined fractions. So you guys have heard of undefined fractions, and that's any fraction with a 0 in the denominator. So if I go back to the original factored form before I cross out, I have to identify what would make this undefined. Like I can't divide and create an undefined fraction. That's no good. That's no good in math. Mathematicians will not work with a fraction with a 0 down here. So once I do this division, this quotient, I have to identify the fact that x cannot be -3 and x cannot be 3 in this problem. X could be anything else. But if I plug a 3 in, I'm going to get a 0 in the denominator, which mathematicians will not work with. And if I put a -3 in, I'll also get a 0. So these two values are called restricted domains, or you could even call them undefined values. Well, it's almost easier to see in this form. Like if you put a -3 in here, -3 squared is 9, and 9 minus 9 is 0. I can't have a 0 here. Well, well, x could be anything in the whole world. Like if we're working with a variable, that means our function is used to solve problems, and we're wondering, what all different values of x could help us work with. So I'm gonna know all the different values of x that'll work in this fraction. But if I put a 3 in here, I get 9 minus 9, which is 0. And this is no longer a function that works. Mathematicians, engineers won't use it. It's no good. So like temperature and width, any physical number, we have to throw 3 out. It's a thrown out value. Okay, does anybody have any other questions about undefined values? Okay. Yeah. If there is a variable in a denominator, then there is an undefined value. Mm-hmm. Yeah. It's talked about a lot more in chapter 7, so it's a little trivial. Okay, so you guys have added, subtracted, multiplied, and divided before. This is something you've never done. A composition of functions. If you want to read about it, it's on page 387 of your book. So, in a composition of functions, the result of one function are used to be put into the other function. It's like f is made up of g. So I'm going to calculate this g function, and whatever I get out, I'm going to plug that into f. That's to be composed of. Mm-hmm. Yes. With division. Yes.
So these notes that we just did, are the problems that we just did, and that's what I'm thinking
So in this chapter of your textbook, the heading is operations of functions, and there's 5 operations: adding, subtracting, multiplying, dividing. This last one's called composition. And you're taking notes on it because you've never done a composition before. I call it fog, but we read it f of g of x. But it's an open circle. It's an open circle on purpose. So in a composition of function, the results of one function are used to evaluate another. F is composed of g of x can be shown in two ways. And it's read f of g of x. So this is an open circle on purpose. And what this actually means it means plug g into f. You take the g function and you put it into f. So I think that this one makes a little more sense because like if you look like the g is inside the f, and that's what we're going to do. We're going to take whatever g is and we're going to put it inside f. But this is used a lot in college algebra, this symbol. But to be honest, on the SAT, I see more than this one. So I like to include it. Our textbook does this. So it varies through curriculum. You know, to be composed of means to be made up of. So this means that f is made up of g. Put g right into f. So here's our problem. I do like to call this fog, but it's not fog. That's a math symbol. F of g means put g into f, and g of f means put f into g. I don't know what symbol's in your calculator, but what'd you say? Yeah. I've always found doing this by hand easier than a calculator, so I've never done this. What? Your calculator really won't do that. Yeah, we're gonna go both ways. Letter A is f of g. So what I'm gonna do is I'm gonna write f. I'm gonna write g side by side. So how I put g into f is it goes right in the x spot. So looking at f, I'm going to circle the variable wherever it is, and I'm going to take the variable out, and I put everything that is the g function right in. It is substitution. It's substituting one function into another. So I have the 2 here. I'll use parentheses. I take the x out, and I put negative 5x minus 1 in. And then I can't forget about the plus 7 at the end. Distribute, combine like terms, and that's the end.
So that just goes out and the 2 goes out.
Yeah, everything stays right in its position. This goes right where the x is. So then from there you simplify. And that's something you already know how to do. This is f of g of x right here. And then you go the other way. Plug g into f. Mm-hmm.
So you replace the x and g with the
Yeah, for golf. So this time I take this one out. And I put all of this right in. Use an open circle. -5 goes, parentheses, keep the -1. So it's -10x minus 36. Let me look, make sure. We'll have to do another example if I gave you any x squareds, because it's more difficult. I think we're good. We can stop there. You guys can use the rest of class to work on your assignment. If you're writing any more notes, I really think that if you guys want to jump down to like 9 through 12, those are more difficult.
I like taking notes like these and break it down.
Okay. 1, 4, 9, 10, 11. It's a lot of work.
So if we do like 1, 4, 9, 12 then?
Like the one day lessons where I do something. If I thought you would remember it doing less, then I would say you. Oh, you have to do all three of those problems for this one? Yeah, but 1 and 4, all of them. I didn't even So, like tomorrow, I'm going to show you how to do 15 through 20. Is that easier?
Attention all students and staff. Shortly we will have a fire alarm. This is only a drill. We will be evacuating, but it is only a drill. Thank you.
You guys, due to the fire drill, let's shorten it a little bit.
Let's go.
Let's do 9 and 11. And you can skip 10 and 12. No, I mean you still have to do 1, 4, and 9. Let's go out to the 11. Out to the 11.
Yeah, I know. Yeah. Send me, please. Thanks. Abia.
It's the ones that are circles. They're actually really It's loading.
Let's put Ariel down.
That's Jake.
Because she's like not in her right mind anymore. She's literally pooping and peeing all over the house. Yes. Like every day we come home and she's always... Yes. Bruh.
Pi? It's pi.
What's the square root of negative 1? Something, it's I. What's 2 times 2 times 2? 8. Some pi.
Some?
That's a Greek symbol for some.
I don't know.
That's what we do every day, Jackson.
No. Did you hear that? Max did it. That was me. Huh? Yeah, okay, you have it. Oh. I'm sorry, Max. No. Is that 2? Is that the second problem? What is she doing? Is this it? Oh, just kidding. Miss Baldwin, we need to learn this on our own. We do not need your help. Jesus Christ. Jesus Christ. Calm down, Matthew. You're gonna have to piss your pants.
F over G and number 1, you're stuck. Don't cross those X's out. Stop right there. That's your quotient.
Give me that. Please.
Good questions over here. I hope you guys are with it.
It's not funny over there. Math isn't funny. For real.
Yeah, Liz, did you not see that little math poster? I ate some pie.
Are you straining? Oh my goodness.
I was thinking I should read laugh though. That's how mad me. And then when I try to keep it straight,
What is he talking about? What are you talking about? Oh, okay.
I did -4x plus 5.
I'm just so bored in here. Everything's so funny. I like when she went off on Max. Oh my god. Roasted. Absolutely flamed. Incinerated. I love that word. What's it called? Cremated. Yeah, I know. Yo, bright soda. Bright soda.
Right, soda.
What? Mind my business. No, I don't. What are you talking about? The worst thing I did in 7th period was when I smashed my pinky in between the weights, and then I gave myself a blood blister. What? No, I don't. That is such a lie. You guys have to write more P's on it.